All right, so it's 5 after, and many thanks everybody for saying hello. Hello also from my side. My name is Daniel Lee. I work at EUMETSAT, and I am your host for today. It's good to see so many of you joining us for this sixth and final workshop in our Earth Observation Data Visualization Workshop series. And I think we have a really exciting agenda today. So thanks to all of you for taking the time to be here, and especially for the speakers who are sharing their expertise and are taking a lot of time to be in the session and also to prepare and maybe answer your questions afterwards. I will start with some logistics. So as a reminder to everyone, by registering to this workshop, you've agreed to be included in the recording. So this session is being recorded. Check that you're comfortable with that. The purpose behind that is so that those who aren't able to attend for whatever reason can see the talks after they're done. So we hope that that's useful to you. We will be cleaning these recordings up and posting them to YouTube, and Rosa's already posted the link into the chat where you can find the previous sessions from the same series. By default, your microphone and camera are turned off. So if you want to be seen or heard, you can request it in the meeting controls. Please have understanding that with as many people we have in the room right now, it's about 300 people. We can't open it up to everybody at the same time. That would just be chaos. But we are very excited to hear your inputs and to see what you have to share and say with us. And note also that there will be dedicated time for that. So we're very happy to collect your questions and your comments, and we will work through those in the Q&A session. So please, if you have a question, the best place to post it is into the Slido. Why the Slido? Because everybody can see the questions in the Slido and can upvote their favorite question. So that gives us kind of a voting system that gets, I would say, the most popular questions answered first. And if you want to direct a question to a specific individual, mark that person in your question and we will get that question to them. Before we start, I'd also like to acknowledge the organizers, which are EUMETSAT, ECMWF, Mercato Ocean International, and the EEA. And of course, this is funded by the EU Copernicus program. So what are we doing today? Well, as you probably have noticed by reading the news for the past 10 years, we are experiencing very exciting times. And especially in the Earth observation business, I think this is a really cool time to be involved. We've never had access to so much data with such a large quality and coverage and timeliness. Just the quantity of data and variables that are being observed and the speed at which they're available and the ease with which they can be used opens up lots and lots of possibilities. This is a very powerful tool to have at our disposal. And yet, at the same time, the challenges facing us as a species and our planet have never been greater, thinking about climate change, but also various other geopolitical factors, all of which is relevant in the context of Earth observation. Earth observation data, when you combine it particularly with other geospatial data, is driving our understanding of the planet, and it's driving the decisions that transform that planet. So this data isn't just a set of numbers or coordinates, it's really the language that our planet's using to narrate its story. And if we as a species want to influence that narrative, we need to be able to tell the stories that will drive action in a way that is beneficial for us as a society and for the planet as a whole. And so that's kind of the overarching theme, bringing together all the things we'll be talking about today. I'm going to share the agenda now, so bear with me for a second. So we're starting off with an introduction from me. That's basically done. And then we will be hearing a presentation by Ignatius Williams from the University of Ghana, showing some of the things you can do with Copernicus data. Then we'll pass the mic to Paul Fisher from the European Space Agency, talking about climate infographics. And after that, we'll hear from Annamaria Loungo, who will be showing how she produces the image of the day, which is a really exciting feat that I like to follow myself. Then we'll take a short break and have a Q&A session. So what unites all of those is that during the first half, we've got talks from experts in using EO data and visualizing it. And it's my hope that with this workshop, we can also be bridging the gap between interpreting that data and telling stories with it, stories that motivate people to do things. And so in the second half, we'll be hearing from Fabrice Messal from Mercato Ocean Internacional, talking about WEkEO and opportunities for media there. And in that same vein, Noemi Marsico will be talking about EUMETSAT opportunities for media. And then we will wrap up with a view of best practices when working with these data sources from Ben Loveday before we go back to one final Q&A and close out the session and the workshop series. So that is our agenda. I'll stop the share now, and we'll hand over the mic to Ignatius. A few words to introduce him. So Ignatius is from the University of Ghana. He has got a decade of experience working on national and international projects, focusing on Earth observation products and services, specifically for marine and coastal areas management. And he's currently at the helm of capacity development for GMES and Africa project at the University of Ghana. So welcome, Ignatius. Very glad to be here.
Hello, welcome everybody. Thank you very much, Daniel, for the introduction. And I'd like to delve straight into the presentation, if I have your permission, Daniel.
Yes, please.
Okay, thank you, everyone. I'll be talking today as part of the EO storytelling series. I'll be doing a presentation on enhancing safety at sea through the use of Earth observation data. This is a use case scenario for the use of Copernicus data, especially in West Africa. So I'm going to start off with a bit of a controversial slide. I'm sure everybody's familiar with the image I'm showing here. And it comes from the movie, The Titanic. Everybody has a perspective in which they remember this movie. Some would remember it as a love story. It's also remembered as one of the biggest controversies of all time. Could Jack have survived if Kate had moved over a little bit to the left on the board on which she was floating? And from my perspective, I see it as what it was, an accident at sea. But I'd not want to spoil the whole presentation for you. But one thing I'm sure about is this presentation is not going to be about Jack or Rose or the Titanic. I'm going to be talking about artisanal fishermen and artisanal fishermen in Africa, as depicted by the pictures you're seeing here, are usually going out to sea in small dugout canoes, like you can see from the first plate on the left, and they have limited means of communication, as well as little to no safety equipment at all. We have about 10,000 artisanal fishermen in Ghana alone, and about 120,000 along the coast of West Africa. Unfortunately, most of these guys rely on traditional knowledge to navigate, to locate fish, as well as to detect the weather at sea. I once interviewed a fisherman from Sekondi, one of the towns, coastal towns in Ghana, where he told me about how he has been able to predict the state of the ocean or the weather at sea by just dipping his toe in the water. And these are some of the many tales that you'd hear from artisanal fishermen across the length and breadth of the coast of Western Africa. There are clearly some needs that have been expressed by some of these artisanal fishermen, being the need to access accurate and timely information on ocean conditions prior to embarking on their fishing expeditions. The challenges and the losses are uncountable, ranging from the loss of canoes, fishing gear, and the ultimate price is paid with lives. These are some of the stories you'd hear usually about people and accidents happening at sea, either due to violent tossing of waves or most often due to the lack of visibility. And because these are tiny canoes and they do not have any form of reflectors or lighting systems, they usually get run over by bigger vessels when they are out at sea. In trying to address this particular problem, we had several initiatives, starting from the Monitoring for Environment and Security in Africa project, which looked at the beginning of the service, which was being carried out within 14 coastal Western African countries. We're currently in the second phase, and we are expanding this to cover 18 coastal countries. 12 in West Africa, and 6 in Northern Africa. The main aim of this particular service is to inform decision making for artisanal fishermen and also help with long-term analysis, especially for the academic and scientific communities. The main data sources for this are the Copernicus marine data set products that are examples. You have sea surface currents, you have information on winds, as well as information on waves and significant wave heights. So these are combined into simple indices that can be interpreted by the fishermen. An example of this categorization would be all significant wave heights less than 1.5 meters would be regarded as calm, between 1.5 and 2.5 meters would be rough, and then anything above 3.5 meters would be regarded as dangerous. So the service has undergone a lot of evolution over the years. We started with a bulk SMS distribution service where we would relay information on a daily basis to coastal communities and individuals along these beaches. And we realized this wasn't sustainable enough. And as the project evolved, we came out with a USSD code for Ghana and Nigeria, which you can see at the bottom left-hand corner. So for anybody joining us from Ghana, you can just dial *920*88#. It's free on all networks, and you should be able to have the ocean conditions. And these are interpreted with messages such as this, or planted with flags in local communities where you have green representing calm, yellow rough, and red dangerous. There is also Android and iOS app, which has been developed for those who have smartphones and are capable of understanding the complexities of the map. You can just go on this map and then download this information, which is made available in English, in French, as well as in Portuguese. You realize that you've got different categories of users who are using different applications. So you've got the artisanal fishermen who would usually have a non-complicated phone, who just want to dial in and get information via the USSD code. You'd have the academics and the scientific communities would want to get information more on the maps and then long-term series analysis of the products. We are enhancing the use of these products by engaging in coastal communities, making sure we build awareness as possible, reach out to radio engagements with local leaders in all the countries that this particular service is available in. We do cherish some of the feedback that is provided by our users, and we try as much as possible to also integrate some of this feedback into improving the service as it goes on. So we've had countless amounts of feedback indicating the effects or consequences of people not heeding to the warnings or the alerts that had been sent to them as a result of the service. And we have an example over here where an alert was sent in Liberia, but unfortunately, maybe they didn't get the information ahead of time. So there were 4 fishermen who lost their lives as a result of this. So we're trying as much as possible to get feedback and also use it to improve the service. We've received numerous calls to include voice messages in local languages. So we are trying also as much as possible to improve the service going forward. So we are now extending this service to cover North Africa as well, and also extend the USSD service in all the 18 countries and not just Ghana and Nigeria. We started the process of integrating a dial-in service to have a local language service to translate everything that would be in text, and also to include very vital information such as rainfall in the Ocean State Early Warning Service. In Ghana, this particular service has been integrated into the mainstream activities of the Ghana Meteorological Agency, and now they have a fully fledged marine weather bulletin that goes out to all the coastal communities on a daily basis. It includes parameters such as sea surface winds, visibility, sea surface temperature, significant wave height, and currents as well. And then it always goes along with the corresponding color codes, which makes it easy for the fishermen to understand the message. And we also collaborate with as many stakeholders as possible. This is an example of where we had a meeting with the Kenyan Fishing Gear Owners Association of Ghana to be able to inform their members and also train them on how to access and be able to interpret this information when they do receive it. I'll just leave my last couple of slides on the other services that we do with the Copernicus data. We also have fishing zone maps, mangrove extent maps, coastal vulnerability maps, and our new service that we just added is the oil spill occurrence maps. If you need more information on the services and the products that we generate, I'll then treat you all to visit our website and our social media handles, or you can just send us an email at rmc@gmes.ut.edu.gh. I'd like to end here looking at the diverse list of participants that we have here. There's only as much that I can fit into my slide, but wherever you're joining us from, I'd like to say a very big thank you for your attention. Thank you very much, Dan.
Medasi Ignatius. Okay, I'm noting that we have the Q&A session coming up in about 1 hour, or in about 30 minutes, I should say. Nevertheless, if you have a burning question that you want to ask Ignatius right now, now is the time for it. I'll give about 30 seconds for anybody to type furiously into the Slido. Okay, well, thank you very much also from my side. That's really encouraging to see the work going on. Yeah, wish you a lot of success as you continue to build these services. Going to hand over to, oh, there is one. Okay, we'll save that for the Q&A session. So the next speaker is Paul Fisher from the European Space Agency. He's a communications officer there, and one of the key activities is communicating on the science outputs of the climate change initiative that ESA runs, which is an R&D program developing long-term global satellite-derived data records looking at essential climate variables. And so I'm very excited to hear from Paul talking about climate infographics. Paul, the floor is yours.
Thank you, Daniel. Hello, everyone. Right, let me just switch to my screen. Hopefully you can all see that. Am I sharing it? No, I'm not. I'm now sharing it. So you should be seeing my presentation. Yeah?
Yes.
Good, right. That's the first thing. Okay, so title of my presentation is called Exploring Data-Driven Little Pictures. Hopefully that's sort of self-explanatory about what we're doing, but let me just give you a bit of background and show you some of the examples that we've produced so far. Right, so ESA, for those of you who don't know, is the European Space Agency, and we have a program called the Climate Change Initiative. We do pre-operational research and development, basically looking to develop the long-term satellite records for a variety of essential climate variables. So we have things like oceanic variables like sea level. We're looking at clouds, lakes, river discharges, a new one. So we're creating satellite data sets that are used to characterize the climate. We do the algorithm development, the processing chain setup, and then once we have it in a mature place, we transfer it to operational entities. So we pass on the annual extension to our colleagues in EUMETSAT and ECMWF. So we're the research arm, and then pass those data sets over, just to give you some background. So we have a lot of data, masses and masses of data. And if you're a journalist or a data visualization wanting to get your hands on this data, it's traditionally not that easy. So the data are firstly produced for scientific use, and they're in a format called NetCDF. Those of you who don't know what a NetCDF is, think of a highly complicated Excel spreadsheet spread around the earth. It's like a 3-dimensional spreadsheet, so it's not the easiest format to get your hands on if you're new to them. And then you also need to know about the specific variable you're interested. So what I have on the screen is just a screenshot of our data sets related to soil moisture. So you need to know whether you want an active product, a passive product, or a combined product. You need to know which version, and it's just complicated even to access the data and access the right data set. If you know what you're doing, you can get hold of those. They're all openly available, and the link is at the bottom of the page. But what we wanted to do is make these data more accessible to people who can tell stories, who can data wrangle and create something beautiful that could increase the reach of the data. That could be a graphic designer, a student, somebody working on social media, or a newsroom. So over the last few months, we've developed a project called Little Pictures, and Little Pictures is a data visualization sandpit where we've put together an informal collective of data visualization creators who are interested in climate to see what we can do and what impacts we can potentially have in the future by generating data-driven pictures. So what are these little pictures? Well, we have an example there, which I'll explain in the next slide, but they're supposed to be super simple and not supposed to be an impenetrable scientific figure or a graph. They're supposed to emote or get you intrigued or interested to some degree. And importantly, I guess, for the context of this conversation, is that they're driven by relatively simple CSV files, and we put together a range of our greatest hits. So taken samples of our data that can be easily manipulated by, let's say, a non-climate data expert. The idea behind that is it democratizes the access. It gives easy access to the data, and from our point of view, gives people an opportunity to increase the reach or engagement with the data that we produce from satellites. So the next few slides are going to give you an overview of some of the outputs that we put together. Let me go through the anatomy to start with. So my creatives have taken a revised Bauhaus approach. That's the arty way of saying it's just supposed to be clear, simple, and functional in what we're showing. We're not trying to show maps like we would do traditionally. We'd overlay, say, the land surface with soil moisture data or another variable. We're using minimalist graphics to get our message across. We tried to put in an emotional hook, and then behind the data, we will have hyperlinks that explain the story that the visual is based on, the data sets behind it, the instructions on how to recreate this if you wanted to, and then data on the bigger picture. So everything is fully citable. So let me just explain what this image is. It's each of the green block is representing an essential climate variable. We're looking at 27 of them in the climate change initiative, so we have 27 of them, and the emotional hook is that first one. It's a domino effect we're trying to get across to demonstrate that all these variables are interconnected, and that's the main message which you put in text at the bottom of each picture. So that's the first one. I'm going to go and show you some other ones which have a varying range of ease of understanding. It was really our journey to put these data together as images to try and get across a message. So here we go. It's worth noting, actually, they're not all ESA data. We have used data with EUMETSAT and ECMWF. So there's a melange of data from the three agencies here. Okay. This page is really just showing you the sort of background text that we have with each graphic. So how we put it together, where's the code, the licensing, and that sort of thing. So here was our first go. It's called an ion ice loss, and it's really trying to show the difference graphically between the size of Arctic sea ice, or the extent, in 1980 compared to 2016. Very simple. It's one message, and it's there to gain your attention, pique your interest. Actually makes my eyes go funny, that one, but we've got different versions of the same thing. So black and white we're using, and we have the 1980 sea ice extent versus 2016 sea ice extent, and it's showing how it's reducing, basically. Played around with animations. So I remember hearing a news article from the BBC about Arctic sea ice, and it talked about the annual heartbeat of sea ice growing and reducing, and that's where the inspiration for this came from. We also played around with this because social media, if there's something moving, people play around in it, so it helps increase the reach. This version, we've introduced a little bit of colour. So you can see from the two circles, we're showing the differences in sea ice over those two time periods, and we're demonstrating the variable with the breaking ice as well. The title is Sea Ice Loss, and it's there just to pique somebody's interest in a Bauhaus simple style, to generate a piece of art. So it's not necessarily targeting scientists. It could be of interest to people who aren't scientists, and it will just pique their interest and get them to find out more. Okay, so then we switch to sea level. So we have sea level rise over time. Looks relatively familiar in that it's a stylized line graph, but it gets across the point that sea level is going on an upward trajectory. I added this one. This is possibly going a little bit too far in the abstract nature. So for those of you that aren't sea level experts, the average rise is 3 millimeters per year over the satellite era, so from the early 90s. And there's an exponential increase if you look at the graph. So we've just put the number 3 there and tilted it looking back. For me, it doesn't particularly work, but some of my colleagues really liked it. Any feedback on any of these would be good, but I think you can go too far in trying to simplify your message in some circumstances. Here's another one that I have trouble with. So it's called virtually coastal. So we can use satellite data to look at coastal sea level rise. This, believe it or not, is a map of Europe. And these are virtual points around the coast of Europe that looks at sea level rise. Important to look at coastal sea level because the coast is where you feel the impacts. And you can see, or if I explain it, you can see the darker the blue, the more the sea level rise. And actually you're getting sea level rise more or less everywhere across Europe's coast. Possibly a little bit abstract, I think, but it's useful to just try these things, which is the idea of what the project was. Moving on to more firm ground, looking at forests. So losing trees and deforestation, you lose more carbon than you gain from reforestation. It was based on a paper, and the circles on this represent carbon. And the seesaw is that you lose more when you deforest than if you reforest. Possibly a little bit abstract, but it's useful just to play around with these messages. It could be useful from our point of view to support an article, to have it as a PowerPoint slide at a presentation, to animate it as a video on YouTube, but also to put it out on social media. And then this is the final of the graphs that I'm going to show you. So we have two examples here looking at burned area, so area that's been affected by fire. So on the left, we have vertical lines for individual countries, and the pattern over years going from 2001 at the top down to 2020. And you can see there is a pattern of burned area. We're starting to see more burned area as time goes on. For me, it gets quite busy. On the right-hand side, we just looked at the top 12 countries in Europe to see how the distribution varies. They're pretty, they pique interest. The question is, does that single message get back to the user? When I mean the user, the person who's viewing the image. We took it one step further. So you'll have all heard of ChatGTP. Colleagues put in ChatGTP and made a computer game out of the data. So this is looking at Arctic decline. Now, if any of you know Pong or Bat and Ball and are about my age, this might mean something to you. So that's your first screen. So we've got Arctic decline, and the length of the ice sheet matches the Arctic sea ice mass. Okay, so that's the introduction. And this is what the game was. So your paddle at the bottom will decrease and increase with the amount of mass loss for a particular year. And it's a way to just gamify the data. And I can see these sort of things working in informal education sessions, online, at events. It's a point of interest, and there's an underlying climate message with it. So what did we learn? Keep it simple, stupid is the message I have. The simpler, the better. Just have one message. Don't try and replicate a whole scientific paper into one graph. Keep it simple. Don't be too clever. Don't be too abstract. You just lose the message. And my yardstick is if if you can use fewer words to make the visualization understandable, the visualization is doing its job, doing the hard work for you. So, right, we have open access data. We now have some greatest hits CSVs of our climate data that makes it available and democratizes it to people who aren't specialists. If we have bespoke requests, say in response to marine heat waves, it's quite tricky to respond to all those requests. So is that sustainable for us? Is there an opportunity for us to generate very simple Python scripts that people can change the time and location and generate the data sets themselves? That will make it more useful for people who have some Python experience and release us from managing new data sets each time there's a climate event. And perhaps there's a role for us as ESA to provide tutorials to help upskill data visualization experts. So our next steps, we're going to start using these data in our news articles and social media. But for the wider world, we're also going to develop a competition over the next few months, encouraging people to build their own little pictures. They'll pick some data, they'll apply a visualization tool and submit a picture to us. That's going to start in September, so keep your eye out on the ESA website over the next coming months for that. ECMWF and EUMETSAT will be co-hosting the competition with us. As the competition is out there, we're going to be promoting it at the ARS Electronica Festival in Linz, and I believe there's 15,000 data graphic designers there, so that's a good opportunity. And we're also going to be promoting it in Lisbon at the European Journalism Centre Summit in October. In the winter, we'll be having a masterclass ourselves at the WCRP's Open Science Conference, which is global and in Rwanda. And we'll be announcing the competition winner there. So this is just my advert. Please can you keep your eyes open for the competition when we go live. Sorry, Daniel, I've overrun. I'm going to press stop now. And thank you very much for your time, everyone.
Thanks very much, Paul. I've been watching the questions roll in on the Slido, so I think you've got a lot to answer for, sir.
Sorry.
No, it's good. I'm glad to see everybody's as interested as I am. I find those images really striking, so super cool to look at. In the interest of time, I'll say let's save those questions for the Q&A, and we'll segue straight over to Annamaria, because, well, Annamaria, you've also got really, really great images. I am not on Twitter, but I follow the image of the day on the Copernicus website and really enjoy that. So looking forward to hearing your talk.
Hello, everyone. the first thing, let me share my screen. Okay, can you see my presentation?
Yes, now we're seeing the slides.
Okay, so hello everyone, good morning, good afternoon, where you are around the world. So I want to, let me try, okay, I can change my slide. Let me outline my presentation. I want to introduce my first part of the story, that is my personal story, and after I want to introduce the Copernicus image of the day stories, because they are related one to the other. So let me start with this image, that is an image that I tried to share in the first webinar, but I have several technical issues in the presentation. So this image is an image of the wildfire of the Vesuvio that started in July 2017. I'm Italian, and I saw this smoke cloud from the window of my laboratory at the University of Salerno. I was involved in remote sensing research activities of my department, and I started to go through the satellite images that were available. And the first image that I saw was the image of Modis Terra, and the smoke cloud was visible from the satellites. So I was impressed because my researches were related to ground deformation, so not the optical Earth observation activities. So I decided to create an image that was related to the ground truth. In the bottom, you see the image that I captured from my laboratory, and I put all together, and I discussed it with my colleague if it was really interesting for them or not. And the answer was no. And I was a bit surprised because we had this huge problem in front of us, but no one was interested. Some day after, so the day after the event started, there was a Sentinel-2 image acquired by Sentinel-2B, a satellite that was launched 3 months before. And I published this image on social media. And I started discussing with the public of the social media on what was the image and what the image displayed. And after I decided to move on, I visualized the data of the Copernicus emergency management service related to the wildfire, and also the EFIS data, that are data related to the extent of the wildfire, and I put together on social media. What was the result? The social media manager of Copernicus CMS retweeted with the comment my content, and I was surprised because, okay, I'm in my laboratory, I'm alone, no one is interested, but someone from the Copernicus emergency management think that my job is interesting. What is the result? The result was at the time that I received a call, and the social media manager that at the time managed also the communication on Copernicus EU proposed me to move in Brussels, and after 6 years I'm the database lead of the Copernicus support office, and I'm involved also in the communication activities of the Copernicus emergency management and Copernicus marine service. What I'm trying to say that the images that you put on social media can help you to tell a story to your public, and this is the secret of the images that I produce every day now, in particular the image of the day. What is the image of the day? The image of the day is a story, a new story every day, and the aim of my images of the day is not create something complex like Paul did explained 10 minutes before, but simple to visualize. But my aim is to put together the complexity of the satellite images, translate this complexity, but for the general public, not for scientists, because the point is give them, the general public, the idea that the satellite images, the open data, in particular of Copernicus, can have an impact in our daily life. And this is a mission. It's something that can take your time, your days, but this is a story, another story. And before to move on, I want to give you just an idea of the impact that can have today. For example, you see here that since the 1st of April of 2020, the day in which this series started, I published more than 1,000 of images of the day, and this image is also published on social media throughout the social media of the DigiDefis Twitter. And there is also a mail related to the image of the day that go through the general public and the media. And the result is that the image of the day is everywhere on all the top media outlets around the world, like Associated Press, Reuters, BBC, and I received personally several requests for the images. But why? Because the image is simple. The image translates a complex message, and everyone can understand this message. And for example, this is one of the most impactful images that I produced. This was the image of the land surface temperature of Siberia for the heat wave of June 2020. Why I mentioned this? Yes, this image got several mentions, but this was the first image that had a real impact on the media, and from which we really started thinking about the effect on climate change on the Arctic. After this image, the attention on this topic raised. So this is the real impact of the image of the day. Another image that I want to show you is the image of La Palma. This is a data visualization that I created in 2021 that wanted to display the evolution of the lava flow of the eruption. And why I created this image? Because the Copernicus Emergency Management, with a huge effort of the entire service, produced an image, a new data set with the map of the lava flow every day. And the idea was how I can visualize this evolution with this data. And I decided to create this evolution changing the color of the map. And the result was that in all the media and in all the television of in Spain, the image was displayed more or less every day. So here you see another example. For example, in the middle, you see an image of Copernicus, a simple RGB visualizing nature. Why I mention this? Because nature for scientists is something related to science. So important things related to new discoveries. Instead, this was a big achievement for me and my team, because we had an RGB in a news item referred to the scientific communication, high-level scientific communication. So the impact of these images is huge. But what is the process for the creation of the image of the day? My process, my personal project, every one of us can have a personal process, is asking if we have particular things that we want to display. In particular, in my case, the first question is, what is interesting for my public? I mean, I'm displaying something that is quite boring, is interesting because it is related to the news. I have a personal idea that I want to display because my attention was focused on something that is not really mentioned by the newspapers or some scientific papers. So select an idea, and that can be interesting for the public. The second thing is, how can I visualize data? Okay, my aim is to translate complex things in simple things. But what is the process? The process is to find the right satellite that allow me to translate this complexity. And this part took a lot of time because I have to realize what is the satellites, what is the best script to pre-process the data, select or reject an idea. After that, the second major part of this process is the image that I create is really what I had in mind at the beginning of the process. If yes, I complete the image of the day, but the process is not over because the aims is always the same. It is simple enough for my public. If the answer is yes, I can publish the image of the day. Otherwise, I spend one day, for example, but I have to reject my first idea and I don't have an image of the day. So the image of the day is something that can be very challenging, but what is important for the image of the day? The motivation. The motivation is one of the major part that you have to create, you have to take in mind when you create the image of the day. And in addition to this, you have to put together all your skills and your open data, because you have to use for sure several tools, for example, WEkEO or the open data services, QGIS, Jupyter Notebooks, etc. So I want to explain you, for example, one of the latest image of the day that I produced. What was the process? This is just an example. How I started with this production with an in-situ image that I captured from the plane in Stockholm 2 weeks ago, because I went in Stockholm for the Copernicus 25th anniversary. And if you see in the middle of the image, there is an area that is brown. And I thought, okay, what is this? And immediately I realized that it was related to the drought. The next step was check if my idea was right. And I checked the data of the Copernicus emergency management, in particular the European Drought Service. And if you see in south of Sweden, there is drought. But I cannot produce this image for the general public. What is the translation? What is the real impact of this kind of situation? If I check the satellite data, and in particular Sentinel-2, the time series Sentinel-2, in this case I used a script that is in WEkEO, I obtained the time series of the NDVI, so an index that put together the stress of the vegetation. And if you see in 2023, you have the lowest value of the curve. So my idea was, since the first moment, okay, I'm right. I have this data that confirms that this is drought. So I downloaded the data and I went in QGIS because my visualization are simple visualization, are related just to an RGB composite and stretching of the images. I put together some additional geospatial data. Here are not visible, but there are the labels of the city. And what was the result? I got an image, but this image doesn't show really the drought because you have just one image. So I decided to download the other image of the year before, because in the time series there was the confirmation that the year before there was drought. And this is the result. The result is the image of the day of south of Sweden, in which is visible that in 2023 there is a lack of vegetation related to the drought that is ongoing. So let me wrap up. What is the image of the day? The image of the day is something that gives you an understanding of how you can use Earth observation data to tell a story on your public, but you cannot forget that you have to be critical and you have to fact checking. You have to fact check your information, because sometimes the data doesn't display what you have in mind. So if you have any comment, this is my email and my contact.
Okay, thank you very much, Annamaria. Those are super inspiring images, and you've
Yeah.
inspired also a lot of questions from the audience. I'm
Thank you very
going
much.
to, in the interest of time, shorten this Q&A session to as short as possible, meaning that we can take per speaker a maximum one question. So I'm starting at the most popular. And most popular question is for you, Paul. Is it possible to order the beautiful posters somewhere that you've been showing?
We had a website with them on that was a test website. It's down at the moment, but we'll be launching the competition with them available early September. So keep your eyes open on our Twitter account at ESA Climate, and we'll be putting announcements out there just after the summer. But the request is flattering. Thanks.
All right, thank you. Next most popular is for Ignatius. Ignatius, how hard was it in the beginning to engage with your users?
It wasn't exceptionally hard. I mean, this is something that the fishermen were already looking for. So it was information that they were already ready to receive. So it was all about just contacting them and then making the appropriate visits to their leadership. And once you go through that chain of command, it's not that difficult reaching out to the main community. So now the leadership of the fishermen now goes and presents the issue and then the possible solutions to them. So you're not doing the work all by yourself, but they understand where you're coming from and they do know how it's going to benefit their societies as well. So they actually, in the end, ended up championing the process and even helping to improve and see through the evolution of the service.
Great, so you're interfacing with existing structures in order to pass on your messages to the users. That's really insightful. Annamaria, I've been digging through the reams of praise for you. We don't have a lot of questions in there, but there's a lot of praise. People really like your work. I did manage to find one question asking if there is a tutorial somewhere on visualizing as an urban planner. Do you have anything you'd recommend there?
Not now. I don't believe exists something. I don't have any idea, but let me think about during the other presentation. Maybe
Okay.
I will put the link in
Yeah.
the chat.
You're welcome also to reply to all of the, and this goes out for everybody. If you see a question that speaks to you, feel welcome to reply to it directly within the comment in Slido. Okay, so thanks very much. We'll have another Q&A session at the end. For now, I'm going to hand over to Fabrice, talking about the very exciting WEkEO platform. So thank you to the speakers who have contributed thus far. Looking forward to hearing from you, Fabrice.
Yes, I'm here. Sorry. So let me share my screen first. launch my presentation. I'm ready. Okay. Do you see my screen?
Yes, we're seeing your screen now, Fabrice.
Okay. So my name is Fabrice Messal. I'm from Mercator Ocean International. I'm a user experience and capacity development manager. And I'm very pleased to be here with you today. Thank you to organizers for inviting me. It's a great pleasure to participate to this data visualization workshop series. So I will introduce you some opportunities for the media to use the WEkEO gas platform and the CMEMS, the Copernicus Marine Service website. So let's start with few words about WEkEO. WEkEO is a European Copernicus data and information access service for share environmental data, virtual processing environments, and with a skilled user support to help users. The idea is to connect all the different Copernicus services portfolio to this website and to offer computational resources to make simulation computation near the data of all these services and to serve all the different audiences, the civil society, institutional bodies, the private sectors, and the scientists. So what you will find behind WEkEO, so a lot of data from the different Copernicus entities with API called HDA, Harmonized Data Access, to allow users to use Sentinel data, model data, and different kind of format of data from the different Copernicus entities. And to share also cloud infrastructure with a Jupyter Lab accessing for the regular users. And if you need more computational resources, you can also have some pay plans to have these resources, this virtual environment. And then, as I said, a user support linked with the different experts of the Copernicus services. So the portfolio, you will find products from the Copernicus Marine Service, Atmosphere Marine Monitoring Service, Climate Change Service, Land Emergency. So in situ satellite and model data, charts, maps, and data from the Sentinel and contributing missions available on the platform. So I will try to make a demo from that. But what are the opportunities for the media? You access to this different portfolio, very complementary for activities which needs several type of data from land, ocean, atmosphere, climate. For example, if you are looking for phenomena near the coast, you need land data and ocean data, so you can have access to all this data from WEkEO. A visualization tool to compare and choose the relevant data first before to download the data or to access the Jupyter to play with it. So the API to access all the products. Again, the strong user support because they make a great job to help people. A Jupyter to start playing with the data is an offer for all users. So you have just to register, it's open and free. And then you can access to this Jupyter Hub and with a great Jupyter Notebook gallery with many examples, piece of codes you can reuse, you can upload directly on your space on the Jupyter Hub. But before, let's start to make this starting the demo with the viewer. So thank you, Annamaria, for the introduction. So let's try to do like Annamaria. Okay, this is a very quick demo. So this morning I tried to find a phenomena I would like to explain through the viewer. So I see there is important drought in Mexico in June. So now, so let's see what we can find on WEkEO. So I will close my presentation. I will dive on the website now. So this is the WEkEO platform, and I can directly enter to find the data here on the catalog. So when we talk about drought, we have the idea of vegetation and moisture. So let's see if we can find something with a different portfolio. I know that Sentinel-2 will give access to SAR images and moisture index. So let's try to add some maps. Okay, moisture index, add to map. Okay, I have to zoom because this is a big volume of data. So I zoom on the region of Mexico. I will try to focus on this region in particular. And then I will play with data. Okay, I have this data. The 6th of June is perfect. So I can see this region. The color in red show me that there is a low level of moisture. Let's try to compare with another date in the past. So for example, in 2020, at the same date, so in 6th of June, okay, May, June, I can play with the timeline here. Okay, 7 and 4. I can have the 6. Will be better if I can compare. Okay, I have this image. Okay, and the idea is to download the 2 images, try to build something with PowerPoint. You can create an animation, a quick animation with these 2 images. So back to the presentation. Okay, so I have the 2 images, and now I have this animation, and I can compare. And effectively, there is a big difference between 2020 and 2023. So I can illustrate this news, for example. So wow, thank you, Annamaria, for this advice to use the WEkEO platform and the different Copernicus platform to play with data. It's very efficient if you use like this. Okay, so next, I will show you now how to play with other data. So and to practice on the Jupyter platform, for example, if you need to make some computation with data or to download data, to play the data, to make your own maps, your own graphs. So you need to use the WEkEO platform to download the data. So back on Europe, for example, I will try to use this Olshi products, and I will try to focus on the 6th of June or the 16th perhaps of June. I saw a sort of 80 here. Yeah, it's beautiful like this. So I need to play with this data, this image. So I would like to download the data and to upload the data and play with it on the Jupyter Hub, because once you are registered on the WEkEO platform, you can access the Jupyter Hub. It's accessible here. You have just to click. You will connect to your space. Okay, this is my Jupyter Hub, Fabrice Messal. Okay, I'm in. So now what I would like to do is to upload the data, but I don't know how to do that. So going back to the website of WEkEO, I go directly on the user support, help center, and go for HDA, because this is the name of the API to use to download the data. What is HDA API client? How to use it? Okay, let's try to do that. Download Jupyter Notebook example, how to use HGA. Okay, I need this example to do that. So I will download on my computer, and then I can directly upload with this button here the Jupyter Notebook. I will be able now to launch the Jupyter Notebook. I need to choose a kernel. If it doesn't work with the kernel you choose, you can change during your experimentation. So now I just launched the different cells. It's very simple Jupyter Notebook. You have just to play to run the Jupyter Notebook with the button play here, and it will launch each cell. So perfect. When there is a star, it means that the computer is running, the program is running, and when there are a number, the cell is done. So let's continue. Okay, now I already configure my login and password. This is very simple. You will see I directly take from the help center the program. So now I need to provide some information about the products and the dataset ID. Where to find the dataset ID? So again, back to my viewer. I click here, information, dataset ID. Okay, let's copy paste. I copy paste and I launch the cell. I will have some information about the metadata of the program, but it's fine. No error for the moment. I can continue. Now I need to create a request and I need to download the data. So to do that, back to the viewer, I will select my area of interest, selecting this feature. Okay, this is my area of interest. Okay, and now I will just click on subset and download. Copy the area of interest from the map. Copy the start date from layer. I need to take 1 day before. Not 1 day after. Okay. And then I can have my API. And now I have just to copy paste this request on my Jupyter Notebook. Okay, and then I continue to launch the query. Okay, I come back here because there is a problem on this part. Okay, this is a good one. And I saw that. Okay, I need to request data first. Choose the date after. Oh my God, I'm not in 2023. Sorry. 2023, June 17, 16, 2023. Okay. State data, job. Here I have my request. I copy, go back here. Oh, sorry. No, this is not. Okay. Let's launch this again. So yes, I have a match. I have an item, and now I'd have to download this file. So let's continue, which change this to download the file on my TMP repository. Now I have to prepare the next step. I need to find a code to visualize this data. I'm not an expert on Python, but I know there is a Jupyter Notebook gallery available. So I will check this Jupyter Notebook gallery. So how to do that? You are on the WEkEO platform here, back on service, sorry, on the home page, Jupyter training material, and this is the Jupyter Notebook gallery. Let's check if we have some codes to visualize all-she data. Oh, this one, exploring and visualizing Sentinel-3 all-she marine chlorophyll products. Let's play with it. I can open directly in Jupyter. Why not? Let's do that. So opens a new window. So now I'm not in my home folder. I need to copy and to duplicate this. So I will copy this Jupyter notebook, copy on my folder, because I can, like this, make some modification and share and save all the modification on my computer. I have my codes to make the visualization. I have my data, but be careful, my data has a format which is a compressed format, Sense3. So how to do that? I'm not familiar with this kind of format. Again, let's go back to the help center. So and 3. Format. In which format the WEkEO data delivered? Okay, Sentinel data. Okay, Sen3, Sentinel-3 data. Okay, I have some piece of code to unzip the file. So I will copy paste all the code and I will launch the file. So I've already done that on my computer, on my instance. I create a Jupyter notebook dedicated for unzip the file. Okay, so I just copy paste the piece of code on this Jupyter notebook, and I have just to launch each cells. Okay, in a few seconds, it will be accessible with the different files. I've unzipped the file, so it's perfect. Now I can play with this one to compare all-she chlorophyll products. So again, change the kernel first, and let's play with it. I just launched the different cell. This one. Okay, this one. I need to be careful. This is not the same product. My directory is TMP, and my file is named like this. Okay, now I can launch. Okay, we're done. I continue. Everything goes well. Oh, not so well. Something is missing, perhaps. Okay, geo coordinates is missing on this part. I don't know what exactly is missing. Okay, I don't have time to redo this this stuff again, but okay. What happened? What happened? You need to add the save directory. I have the save directory, Ben. Thank you. I'm sorry, I have to test just this one on another Terminal.
Fabrice, it's very brave to be doing a live demo.
Yeah, I'm sorry.
Perhaps is there a point where you can skip to show the result, and then maybe we can come back to this during the Q&A? I'm just being conscious of the two other presentations.
Yeah. I will check all the detail, and during the Q&A, I will show you where my mistake was. But quickly, okay, this is very simple. In fact, all of this is to show you that a lot of works already exist on the WEkEO platform in the Help Center, the Jupyter Notebook galleries. So you can have a look on that. You can try to play with the data. There is a big user support to help you on doing this. And last thing I would like to share with you, do I have some minutes? Tell me.
Yes, but please keep it under 5.
Okay, so quickly, it was a demonstration on the WEkEO platform, and I would like also to show you the Copernicus private service with also different kind of products available focused on marine data. We have different tools to visualize the data, and a very powerful tool for media can be the MyOcean Pro viewer, because thanks to that, I will be very quick on that. I engaged you to come and play with all the data. You have this viewer. This is the same look and feel than the previous one. You can access to all the products, and you can dive into the data literally, because, for example, you have 3D model data of the ocean. You can dive into depth. You can play with the timeline. You can change your column map, your boundaries. You can access to the data. You can subset and download the data. And most important, for your quick production of images, and if you want to share something very quick with your community, you can directly focus on your area of interest and just click on the share button here, and you will be able to share an image, to download the image directly, to produce a short animation. You have to be logged to do that, to be registered. Again, this is a Copernicus service, so it's open and free. You have just to register. You can generate a video. You can also embed this view of this product on your website if you need. So it's very useful to have that. And if you have a look on the catalog, you will see you can have access to models, in situ observations, satellite observations, and many products, and ocean monitoring indicators. And last information I would like to share with you today is that tomorrow, come back to my presentation. Tomorrow we have a special training workshop for ocean literacy for journalists and science communicators, organized by the Copernicus Marine Service. So will be a very a good opportunity for you to discover all this service and what we have to offer at the Copernicus Marine Service. Thank you very much. I'm very sorry for this demonstration.
Fabrice, no need to apologize. It's a very brave thing to show a live demo, so it's very much appreciated. I'm hoping maybe in the background while the next presentations are going on that you can put it together, and then we can circle back to that during the Q&A. So it'd be great to see the output of that notebook.
I'm sure Ben will help me to find the solution. Thank you very much.
All right, thanks, Fabrice. We'll go on to the presentation by Noemi, looking at EUMETSAT opportunities for media, specifically focused on EUMETSAT data. So thanks, Noemi. Well, the floor is yours.
Thank you so much, Daniel, and thank you everybody for all the presentation and all the attendees for being here. I start sharing my screen like everybody else, so you can check my presentation. You can probably see it now, right, Daniel? right, Daniel?
Yes, I just couldn't find my unmute button. Yes, we're seeing it now.
No worries. Okay, good. Nice to know, just to make sure. So thank you, everybody. I will be talking, as Daniel mentioned, I will be talking about creating shareable maps with EUMETView, one of our data access services, and I'm really excited to be here and talk to you about this. I will be doing the presentation and sharing some information about how to actually do it. So we also go through a demonstration, and we also have Nicholas Jordan, which is my colleague with me, today, that in case we want to answer some questions, we'll be answering them together. So first of all, just a little bit, just to shorten up about myself, about who I am. So my name is Noemi Marsico. I am an employee of Innoflare, working as external contractor for EUMETSAT. I am working in the data access services, hence why I will be talking to you about EUMETView, and I am one of the training experts of the team. This means that if you have or if you will join one of our training sessions, you will be probably seeing me there. We through our data access services, we work with EUMETSAT data and also Copernicus data. But today I'm here because I have been working a lot in terms of science communication. I have been working in terms of content creation on social media. I've left here the EUMETSAT media and EUMETSAT on Instagram and Twitter. I am not in charge of those pages, but I definitely advise you to follow them and check them out, because they constantly share really incredible images and really good news. But I've also been doing this by myself since I was a student, so it was always been kind of a passion of mine, and I got the chance to collaborate with different universities and also collaborate with Greenpeace. I interviewed the head of Greenpeace Sweden. I'm also involved in IUCN Committee of Education and Communication with Indian schools, where we're trying to teach climate change, and also for is a EUMETSAT social media representative for the MTGI1 Lounge, which I guess you might have heard. If you haven't, definitely check out their last image, the last image of our third generation satellite. And this is a really incredible image, and we're all really excited and really happy about it. So definitely check it out. But why I'm going to talk to you a little bit, just we'll go fastly through this, so I know I'm not going to waste too much of this time to Ben, sorry. But yeah, so we know that the challenge in terms of science communication can be really tough. First of all, we need to simplify what are complex topics. And when you have to simplify something that has been studied for decades in like 15 seconds video or just an image, it can be extremely complex. And we all know the big challenge of trying to achieve this knowledge, and especially also to engage the audience. We know that science has often been seen as a more of a subject instead of just our way to interpret the world. So engaging the audience is also really hard when it's about something so complex. And also here I put explain invisible process. What do I mean with that? Explaining in terms of earth science how we cannot see certain physical processes, right? We can see a flash flood, of course we can see that happening, but then maybe we cannot see an input from a river into the sea of sediments, right? So explaining something that is so invisible to the naked eye can be also really complex. And also sharing unwelcoming news. Welcome news are really hard to share because people don't want to hear them. So it's hard to share, especially when we're talking about climate change and about what it is that people don't want to know and don't often want to hear. But because of this, we have and the incredible power of maps. We believe that maps are one of the best tools we currently have to share science. And this is obviously because they're easily visualizable, they are engaging, they have a lot of colors, they pique curiosity, and we know how important it is to pique curiosity, and especially on media when you have a certain algorithm, and the more people just stop looking at your image, the better it is for your article. So the maps are a really a good tool for us, and has been widely researched that improves problem solving skills, together with a lot of different skills that are improved through the use of maps. Here I left some examples of nice maps, but of course I will also show you the demo of how we can create them. So don't get scared about the images, but these are just a few images that have been created. The top left and top right are created with EUMETView, while the middle one is a EUMETSAT image, I guess, created with Sentinel-2. These images are also a really great way to share information. The first one, for example, is sharing chlorophyll, so phytoplankton biomass, and also we are having ashes on the far right, and also in the middle we have also chlorophyll and sediments. So they are really good maps, really good images that you can use to share on either your social medias or on your journals, or generally to share for improving the information. But of course, creating maps is not really simple. We know that when we are working with data, especially with Earth observation data, they can be really complex. We have a really high number of data because, of course, we are constantly scanning the planet. So when you're not feeling fully confident and fully comfortable with using large amount of data, how can you create a map? It can get really hard. Also, the processes can be long, and if you're not really experienced with this, it might take you hours or days to create an actual map. And it requires quite IT skills. We know that many of our data can be processed through coding, for example. So if you're not feeling fully confident with that, it's hard to create what it is, a good map to share. But this is why we have actually created this great user interface. We have this service which is available as a user interface on your browser, but it's also available as APIs. And also I will tell you later that you also will be able to use it on QGIS. But this is what we call the EUMETView. This is one of our favorite services. It's a really simple user interface that covers a lot of different services. We have specifically 3 services. One is the web mapping service, then web coverage service, and the web feature service. These services are similar, but they differ in little features. So, for example, the web mapping service is a service that allow you to download the actual map. This means that each of your pixel will have then the legend of the map. You will be able to get the information of that certain pixel in terms of the map itself. So, for example, you have a band and it's telling you which band it is. But we also have the web coverage service, and this is more of raster data. This means when you get the information of a pixel, you can get the actual data from the satellite. So, for example, we are checking the the sea temperatures, and then with the web coverage service, you will be able to have the actual data in degrees Celsius, right? We also have a web feature service that works more for vector data, such as, for example, wind speed. And this is also a great service that you can use. And for all the services, we also have APIs, and I will also show you where you can have access to the endpoints. We have different services, we have different data, and we are planning to always improve and increase the amount of data that we have on EUMETView available for all the users. But let me show you how to actually do this. So let me just give me one moment more. So I will be able to share with you my other screen. Okay, I guess you can see the EUMETSAT website now. So how do we have access to EUMETView, to this great service that we have? First of all, you could just simply write view.eumetsat.int, and you will be automatically directed to the service. But here I'm going through the long way, so I will show you how to reach from the EUMETSAT website, just in case you don't remember the direct link. So here we have we have satellites, how to access our data, it's right here. Here we have some information about how to access our data. We have getting started. And here we have all our services, majority of our services. One of them is exactly EUMETView. I will show you also a little bit down where you can have access to our knowledge base. These are our knowledge base, and you can find a lot of information, especially in terms of technical information of EUMETView or other services, of course. And this is, I will not go through it, but it's right here. You will be able to click on it and you will have different pages explaining you everything you need. Also in the link that Sienna is sharing on the chat, you will be able to find this directly. So let's just go up and I will open now EUMETView. It's right here. Here will be open another page. You get just a little bit more information, a video with Ben. And right here, you have the direct link, view EUMETSAT.in. That's what I was mentioning before. You can just click on it and you will be able to open the map. I will take off the layers for the moment, just so I can show you the base map. So here the concept works exactly like Google Earth. Okay, so you can show what we were seeing before. It works also on EUMETView. We can basically move our map, just zoom in, zoom out. You can do it with your own mouse. You can do it with just simple clicks. We also have this little way to do this, just creates a window and zooms in one specific place. You also are able to toggle the full screen, so have it as a full screen or just have it as just to show just as a normal browser, so whatever you prefer. But of course you can also modify the actual base map. So let's start from the bottom. We have projections right here. We have different types of projections. We have the geographic, the spherical, and the North Pole. For example, the North Pole, if you are working with with data in Svalbard, for example, or the Arctic sea ice, then these projections are your projections, and they can be really comfortable. I will use just the geographic as usual, as my usual, and everybody. We also have different types of base maps that you can use depending, of course, on the types of layers that you're using. We have natural earth, we have the dark one, and we also have the light one. So you are free to choose whichever you want. We also have overlays. So the overlays just allows you to choose which kind of borders you want, so borders or labels. We have the coastlines. So as you see here, we have just the borders of the coast, so we can just create it or take it off. And the same for the boundaries of the countries. So you can either have them or do not have them, depending, of course, on what you like. And we have labels. We have two types of labels. So we have the dark labels and we also have the light option. And this is all based on what you like the most, of course. You have also a little scale here. It just allows you to have the coordinates and everything. So it's a really comfortable map. It's just like Google Earth. It works exactly like that. But now it comes the really cool part, which is adding the layers, okay? When you can add the layers, you will be having a new little window opening here. You can choose either you want satellite or you want based on themes. So you can have atmosphere, you can have ocean, weather, whichever you prefer. You have the different types of satellites. So we have the MSG, we have the Meteop, we have Sentinel, and also combined Sentinel A and Sentinel B. And also we have multi-missions. So from here, you can literally add as many layers as you want, as much as you like them. So for example, I will just add a few. I will add Cloud Mask. Here, when you open them, you have this little thumbnail. You will be able to read the name of the product. You can check out in which orbit the satellite is. So this is GEO, for example, and you can also check out the service. Here is the web mapping service. So you can add it, but you can also read more information about the product itself, the collection itself. So here you read a little more, it gives you some description, but for more technical details, you can go to our product navigator right here, and then you have literally all the information you need. You have some resources, you have technical details, and additional information. So you also have the different ways you can download this same collection. But let me go back and add this to the map. You can just simply add it to the map. And then I will try to add another one. For example, I will go for this one, also visualize the product. We can add, or maybe RGB. I can add this dust, for example, add to map the same way. So as you see now, I can make one layer disappear if I want to, or in the other appear. And I can also decide on how much opacity I want. So of course, it's much more comfortable to make one of them at least a bit transparent, so you're sure that you can see all the data that you have. You can literally choose whatever you want. You can modify however you like them. And you can also choose your timeline. So we have different timelines, of course, and we also have, for example, we have the 2 different timelines. In this case, I will show you. Here we have the temporal extent. As I want to show you, you can easily see it here. Zoom out and zoom in also on that. And if you notice here we have it highlighted. This clock is highlighted, and this is just saying that the driving time period is the one of this specific product. Of course, this depends on if you're having different satellites and you're using different satellites, so they don't have the same time steps. But of course, it depends on which ones you're using. And here I'm just zooming in, so you're literally you can go from one image to the other one and just check out and play around with this. But the best part of EUMETView, once you have created this, is to create your own views, okay? So to create your own views, you need to log in. So I will be logging in with my personal username and password. You will also need to do this. So I want to load the view. Yes, I want to load the view that I was having before, so you can keep it. From here, you can either download directly the picture, the image that you want. So you can just press on this map, data download. You have the current map view. You can choose map region, full resolution product. You can choose the current, so I get just this image. I can also choose the format if I want PNG, JPEG, GIF. This is in the case you're using GIS. And you can also decide to add the footer or include legends. Of course, you would have the legends here. And add the footer. The footer will just be EUMETSAT and the logo. And you can just simply start download. This will just start your download, and you will have the image just as you wanted. But really, really interesting, you can also add it in your own views. So if you want to add this in your own views, you click on My Views. As you see here, I have different views. So I can also create groups. I have data visualization workshop, for example. I have my group. I've created this one exactly for today. In this case, you can just add new view. And this is the current view that I have showed you now. So I can just click OK. I can write trial, for example. I can write a description, put it in my group, and also the time mode if I want live or event. And here it's creating. From here, you can simply also just share the view. This is really, really comfortable because you can just click here and copy this link. And anytime you send it, this link will open directly the same image on EUMETView. So even if somebody is not fully comfortable with using EUMETView itself, you will send the link and then it will open directly on EUMETView. And this is really interesting. But I also want to show you a little more images that you can create with a little effort or not, depending how much you like it. So for example, I will show you this one. This is Olchi image. You can see here, this is Florida. This was the runoff plumes that was created after a hurricane. So this is also really, really interesting. You can see here the chlorophyll. So it's super interesting. You can also change the time, but you can check other types. For example, this one you will load. As you can see here, I have two different products here. I can make one of them disappear if I want to. But here you can see the clouds. Look at how beautiful this image is. I have even more images. For example, this is another image. This is also from Copernicus data. So here we have the Brunt ice shelf in Antarctica. You can see it's really, really feasible, and you also can write some description here. And this is the best thing, because in the end of the day, you can create this really, really simply and share it to anybody that is not confident with working with data, and they will directly see the image. It's really comfortable, and again, you will be able to download it really simply. But I also want to show you a really, really interesting feature that we also have on EUMETView. And I will load this image. As you see here, I have the cyclone Batsirai, if I pronounce it well. This is Madagascar. And here we have the best part of these cyclones is they obviously turn around. So I can create an animated map. To create an animated map, I can just simply click on animated map, also really simple. You can decide from where. So here I'm going to choose February the 2nd to February, let's put the 6th. We can choose how many frames per second that we want. So for example, I'll go for a bit more. This is how many images in the second you want. So of course, depends on what you want. I definitely advise you to play around with it a little bit. And you can also choose after how the time frame. So for example, after every 30 minutes or every hour, it depends on what you want. After this is really simple. You can just simply run it. It will take just a few minutes for it to run. So we just have to wait a little bit. But it's the outcome is really, really interesting, because you get to see exactly, here it is. You see how it's moving? You see, it was moving just like that, and you can create the animation map like it. But of course, you can also download it. So once you click here again, you will be able to get same information. This was until the 6th we set, and you can download the animation. Here you will be able to download the size. So of course, if you're posting it on a social media, or if you're posting it on a different website, you will be able to choose the size of your image, and also you will be able to download it as a MP4. This, of course, is really helpful if you're done editing also afterwards. Sometimes it can get pretty hard to edit videos, just the animated map on the EUMETView, but you can just download the MP4 and then use whatever you are using, for example, Canva or CapCut, whatever you feel more comfortable with, and you can download simply the animation. Also, in this case, you can add the footer or include legends. So this is also a really, really great way that we have to download images and to create images. Of course, all these steps are quite simple to do and to follow. It's just like playing around a little bit with it, and then you will be able to create a great image. As I was mentioning before, we do also have API accesses. So if you click here, you will be able to see the WMS, WMFS, and WCS. So these were the three different services I was mentioning before. In the moment you click on it, you will just be able to get the API and just use it on your code. It just works just fine. And we also have, of course, different information. We have shared these links as well. To use the EUMETView as part of QGIS. So you can simply use QGIS, use it as a WMS service, the WMS service of EUMETView, and then import your data. So if you're feeling comfortable with using QGIS, you can also do that. And this is more or less all you can do with the EUMETView. There is a lot that you can check out. There is a lot you can create, and all this information and all these different all these different ways of creating maps. We are constantly working on creating trainings to teach all our users how to use this. So we have also left this in the link to access our data access training resources. We constantly create trainings about how to access the services, either is our data store or data tailor, or the EUMETView itself. We are really happy to also receive your feedbacks, and if you have any question or any interesting comment, anything you would like to learn, we also have that directly on our page. You can just leave on Slido whatever you think, also in an anonymous way if you prefer. So I definitely advise you to check out the links that Sienna have been sending you. And yes, I hope this was quite clear for you all. And thank you so much. I hope I'm not stealing too much time to Ben now.
Okay, thanks very much, Noemi. Super interesting. I love seeing our data services in action. So that was a very comprehensive overview. Very, very useful. Ben, any words you'd like to add, wrapping up and introducing the good practices?
Yeah, I'll add my 10 cents in my last 10 minutes, but I'll hopefully go a bit quicker than scheduled, so we still got time for Q&A at the end. So let me just share my screen. Hopefully, just give me a quick thumbs up, Daniel, if you can see that. Fantastic. Okay, so hello, everybody. Good afternoon, and welcome to the final presentation in what has been a fairly kind of mammoth undertaking, an enormous amount of information that we've provided to you, and an enormous amount of feedback we've got. So in this final presentation, I am just going to tell you really what happens next with regards to all this information and how you can be a part of helping to craft the outputs from this webinar series. But first of all, I want to say a big thank you to everybody that's been involved. Over the last 6 weeks, we've had over 30 people present. They've covered a huge range of topics, a huge range of Earth observation data used. We've had people from the journalist community, we've had scientists, we've had those developing services, and we've had, on average, around about 300 people attend every presentation. So if I'm rather soft on myself, I would say we could have anywhere maybe over 1,000 people attend these workshops in general if people haven't come to more than 3 or 4, which is a fantastic number to have, and to have that level of engagement between ourselves, the data providers, and you, the data users, and those who are hoping to use our data to craft stories. So what have we learned so far? We've learned a lot. We've learned about what makes a good story for modern media, both for journalists and for those communicating via social media. We've learned the kinds of things that Earth observation data can observe through different thematic examples over weeks 2 through 5. Things about wildfires, things about heat waves, things about climate extremes. We've touched on all these different things. We've learned what makes a visualization kind of successful, what makes it clear and understandable or accurate, or what makes it and helps it get attention. And we focused a bit on that in the first section of today. We've also learned a bit on how to access data and what tools can be used for visualization. So how do we bring all this together into something that's kind of a comprehensive guide for you to work with moving forward, bringing together all the lessons that we've learned from these various different avenues of exploration that we've explored? Well, this in fact is the main focus of my short presentation now, and one of the main goals of this webinar series is to create a good or best practice guide for working with Earth observation data. And we've already made some steps towards authoring this based on what we've learned so far for some of the main storytelling points that have come up over the last 4 weeks. So we have a draft structure that is available for you to go and to look at, and this is the link that hopefully will be provided in chat. I can't see it, and this will take you to the first instance of this documentation. I'm going to quickly move my screen over to there now so you can see what it looks like. So this is, as the warning states at the top, a work in practice. It is definitely under development because we've really only started developing it in the last 3 or 4 days or so, and it will take us some time to kind of synthesize all the information that we've gathered from the last 6 weeks together into something that kind of narratively makes sense, because we learned a lot of different things that are helpful but in different kind of sessions, but kind of fit together. So this is a piece of software. This is built on a piece of software called Read the Docs. So Read the Docs makes these nice interactive web pages full of kind of instructive information that are quite good for kind of conveying guides like this with regards to how to use code or how to like take on a specific task. In this case, data visualization with EO data. And you can freely click through all of these sections. And under the introduction, for those who are asking, we have already linked to the EUMETSAT website YouTube channel where all the data visualization seminars themselves will be played. So this actually links to the YouTube channel for the playlist for all 6 videos. And at the end here, if you click on the workshop presentations, then this will actually link out to where all the PDFs for all the presentations will be for the entire webinar series. One thing to note, we want your collaboration to work on this. So this guide itself is written on CC BY, so Creative Commons license that's entirely free and open for you to collaborate, use the information, adapt as you see fit. That is not true of the presentations themselves. You cannot adapt and distribute those. So just be aware, the best practice guide, free for you to work with, but anything provided by any of the presenters needs to stay as it is, and I credit the presenters who gave it. So just pop back to the introduction, and you can see there's a whole list of points that we've already started pulling together here based on those kind of points that I kind of mentioned before on my 3rd slide. So you might want to know, and I hope you do want to know, how do you collaborate with us and kind of pulling this documentation together? We have all the information from the last 6 webinar series. We have all of your questions and comments. We have all of the presenters' recordings themselves, and we'll pull that together into kind of a version 0.1, if you like. But this is not the end of the story. We want this to be a living document for you to continue to contribute to, and I'm going to show you how you do that. So just popping back to my presentation, and everything I just basically said is summarized in this slide here, so I'm not going to go over it again. Oh, apart from the final point, when you do make contributions, I'll tell you how in a second, don't forget to add yourself to the authorship. So we will retain a list of anybody that contributes to the data visualization workshop, and you will be listed as a contributory author in it. So 2 ways that you can contribute. In both situations, one thing you will need is you will need to create an account on GitHub. So all of this documentation is stored on GitHub, and it's all stored via this link down here, this github.com WEkEO eo-data-viz-best-practice.guide. I'm sorry it's quite long, but I needed it to be something that kind of made sense rather than just a load of acronyms. And if you go to that link, then you will find yourself at this web page on GitHub. So all this is basically is all the documentation that I've written and it's displayed on Read the Docs, synthesizing everything we learned over the last few weeks, and it's all hidden in this docs folder. Now, there are 2 ways in which you can help contribute once you have a GitHub account. For those who are not experts in using Git, all you need to do is you can click on this button here and raise an issue. If you raise an issue, then you point to us about the piece of text, or even better, copy and paste the piece of text that you want to be changed with your suggestion for how to change it. And then we will review that as moderators. And then once we've accepted that, we will incorporate that change into the documentation. Let us know who you are, and we'll add you to the contributory authors list as well. For those who are more advanced in using Git, you are free to fork this project and then to make your changes and then to make a merge request back in. And then we will, again, review the content, and then we will accept the merge request if it matches our requirements. So 2 ways you can do it. You'll need a GitHub account for both. Issues if you're not used to working with Git, or fork and merge if you are used to working with Git. So the issues way, all you need to do is raise an issue here, new issue, write what you want us to include, adapt, update, suggestions, and then we'll respond in kind on this page and make the changes. That will then automatically build once we accept it and be reflected in the documentation here. Full instructions kind of given here on this slide. If there are any problems at all, you can reach us at ops@eumetsat.int. That will go to our help desk, and then we'll be able to respond to you with regards to addressing any technical or kind of narrative issue you've got with the content there. So over time, we hope that this iterates, we hope that this grows. We want it, as I said, to be a living document so we can continue to collaborate and make this kind of good towards best practice guide. So what happens next? All presentations and videos from today will be uploaded into the various places and be reflected on the 2 links that I just provided. The team behind the scenes, myself and a load of collaborators, will work through pulling everything together to go towards this best practice guide. Then we'll circulate the first draft and we'll ask you to provide your contributions via mechanisms of your choosing. It doesn't end here. Please free to make requests, things you want to see added to the guide, including new examples. We will try and rope in as many practical examples as possible, both for tools that are available for you to work with EO data and code where we can do it, that helps you actually practically come to terms with using the data itself. And we look forward to future collaborations with you. Thank you all very much. This has been a fantastic set of webinars, and we've really, really enjoyed engaging with you, and we hope to continue to do so. Thanks.
Okay, thanks, Ben. That was fantastic. Right on the nose, too. We are at 4 o'clock, so that is the official end of the workshop. If anybody needs to turn into a puff of smoke, you can do so without feeling guilty. You wouldn't have needed to feel guilty before then anyway. But now we have some time to come back to the Q&A. So as long as you're around to stay with us, we're happy to continue and work through these questions. Before we jump straight into those, though, Fabrice, did you want to go back to your demo? Was there something that you wanted to show?
Oh, thank you. Thank you to give me this opportunity to share quickly my mistake with you and to tell you that the Jupyter Notebook Gallery is amazing, it's fantastic, and the code are running very well. So it was my Jupyter Notebook, so this is my error on the code. And if you remember well, I just upload this Jupyter Notebook from the Jupyter Notebook Gallery. And in fact, the Jupyter Notebook is not at the right place in my home directory. That's why it cannot find the file with the data. So if I use this time the copy I made of this Jupyter Notebook Gallery, and if I launch, I already did this, my file and my data, I will find the correct images I had on my viewer, if you remember. So that's all for me. It works. Thank you.
That is beautiful. Thank you, Fabrice. Okay, so in the last half of the workshop, we heard from Fabrice, Noemi, Ben. Great job showing us how we can access these wonderful data services that give us the opportunity to work with this data. I also recall the presentations of Ignatius, Paul, and Annamaria from the beginning, talking about what you can do with the data. That was also really, really exciting. Now I propose, as long as we have questions that are still open, again, anybody who needs to leave, including the presenters, we understand completely. But I don't mind staying a little bit longer and making sure that the questions that have been placed in the Slido are answered. So let's take a look at what the audience has put in. Starting from the top, Copernicus marine data. There's a question about sea surface temperature. Does anybody in the know about this? Annamaria? Are you familiar?
Yes, more or less. I don't have an idea exactly, but I know for sure that there is something related to the Mediterranean Sea that is included in the Copernicus Marine Data Catalog. I'm not sure about the the data for the global level. I don't know that, but I'm sure that in the past there was data. Maybe there is a new version of the data catalog and a new version of the model, the global model. So maybe it is not online yet or something. Fabrice, I don't know.
You're right, Annamaria. For the moment, the products and the SST anomalies available only on the Mediterranean Sea.
Okay, thanks very much. If I remember rightly, the next question is for you, Ignatius, about the most drastic changes you've observed since introducing your services at the Regional Marine Center.
Right. So I'll start from this angle. The service is not necessarily mandatory, or you're not fixed to sort of abide by what is given out. It's only giving you the option to be able to leave to go out to sea to either fish or not fish. But we have seen some positive improvements in the number of accidents that have been happening at sea, at least with relation to ocean conditions. But there are certain parameters that we still do not have a grip on. For instance, visibility and other parameters where they're still being run over by other vessels when they are out at sea. So it's a dicey situation to put statistics on it. I do not have the exact statistics on the differentials between what was happening as a result of collisions due to poor visibility and actual accidents as a result of waves or dangerous conditions posed at sea. But we can have a general impression that the fishermen are very much aware of the services, and they do pay much attention to it before they go out to sea. Much of the feedback we've received has been positive, because there was a time where we had a 3-day break in communication being able to send out, so fishermen were not able to actually request the information on the various platforms, and we had a lot of feedback coming in. We're not able to get the messages, what's happening, can this be fixed ASAP? And then we're able to resolve most of these issues. But I can say it's been mainly positive on the awareness end, and they're very much happy to utilize this information.
Okay, great. Thank you, Ignatius. Paul, I think the next question is for you. Is there a link for the simple graphics in the sea ice game?
No, that one's behind a paywall. It's more of an experiment at the moment, but it'll be revealed at some point somewhere. So I think the short answer is no, not yet.
Okay, well, we will await the fullness of times then. Next one is also for you, I think, from Chris Gordon, asking if you've considered using AI to generate the visuals.
Yeah, no, I thought that was a really interesting one. I mean, everyone's hearing about ChatGPT at the moment. So the data sets themselves have a lot of AI involved in them to train the algorithms. So it's actually used scientifically. AI has for 5 years, the 5 years at least I've been involved in ESA. We actually have a research fellow working in the climate office, the team I work in, who's a specialist on AI, and I'm going to take that thought away and see what we can do.
All right.
Yeah, thank you.
We'll look forward to seeing what comes out of that. Also from Chris Gordon, about Arctic ice. He says people may have difficulty relating area changes with the proportional change in radius if you're comparing circles.
Yeah, no, I totally agree with him. So if you can remember 2 hours ago when I was showing them off, the images we had were quite abstract. We did play around with putting the difference between 1980 and 2016 as a map of a country. So let's say a particular country like that, let's just take Belgium, and the area of ice loss was Belgium. You could represent it as the area of Belgium, or 2,000 football pitches or something to make it more relatable. So there's definitely opportunity to explore there. But I sort of get what you mean. You've got a small circle and a big circle, but how big is big?
Okay, yeah, thanks. I think we can summarize the next two questions together. Where can we find the greatest hits CSVs, and where can we find the infographics?
Yeah, so the greatest hits CSVs. There's a couple of questions about what it actually means, so I apologise. So those were subsets of our essential climate variable data sets. We've taken the ones that are most relatable for the, let's just say, the public as CSVs. They're not available, but they'll be definitely on the competition website that we'll be putting out in September. So again, check out the Twitter feed, ESA Climate, and we'll be putting out more information that way. The same applies for the infographics. We'll be putting all the examples and the way that they were put together in the same web pages. So something to look for after the summer.
All right, we will look forward to that. So that's those top 2 questions. And Noemi, you've got a question about if you had to pick one advantage, what's the biggest advantage of using EUMETSAT versus Google Earth?
Well, I think of course I'm biased, but Google Earth is great in terms of the base map itself. But EUMETView is actually giving us access to all the EUMETSAT, to majority of the EUMETSAT data and Copernicus data. So it is really comfortable and it's really simple. You can also, once you choose the product, you can see already the little image right there. So I think you have access to really good amount of data and it's really simple. Google Earth sometimes can be confusing, while EUMETView it's really simple to just use. So definitely go for a EUMETView.
Okay. Thank you. Then we had another question. I think Ben's mostly answered this one. Is time included as a variable in NetCDF files? Not in all NetCDF files necessarily, but for our observational data, yes, it is included. So I hope that was helpful. And then Ignatius, we've got one for you. Your services available in Cameroon or Senegal? Question mark.
So it's a no and a yes. So the service is currently available for all of Western Africa, and Cameroon doesn't exactly fall there. It's within Central Africa, so the limits are up to Nigeria. And these are available via the app. Just search it on any Android or iOS device. Type in GMES-UG, and you should be able to download this for free.
All right, thanks very much. Then the next question asks, and I'll answer on Ben's behalf because he's had to leave for another meeting. It's asking for some detailed info about NetCDF as it differs from organization to organization. And I see that Ben already answered this in a little bit of detail. I can only say it's worth looking into the NetCDF format because it's basically like saying text as a format. And you know, text is the format used for every book. You can write anything using text. You can describe anything using NetCDF. So it really depends on which data you're looking at. There are some ways of standardizing NetCDF data, and more or less everybody tries to stick to similar standards. But I think in order to give more detail, we'd have to understand the question a little bit more. So maybe we'll see what a future workshop and we can talk about in greater detail. Next question isn't a question, but I would endorse it entirely. You're awesome, Annamaria. Yes, that's true.
Thank you very much.
Yeah. And also directed towards Annamaria, from Deborah, do you notice more engagement from a particular region if there's a day's image from there? Or is it just more broad where you get your engagement from?
My experience, south of Europe is the most engagement area for the Copernicus images. Spain, Portugal, south of Italy, Greece, Turkey, Cyprus. So all this kind of places are very active on all the images that we share. And they are active also for the images that are related to the effect of climate change in their area. I believe that is a bias related to the effect of wildfires, news in general, but they are more responsible respect to Germany, for example, Sweden, and the countries of the high latitude. So at least this is my understanding and my know-how.
All right, well, thanks very much. Then we have a question, Fabrice, I'm wondering if you can take this one, asking about the WEkEO APIs and how those differ across products.
I think this is like the name is well represent the API. This is harmonized data access. So it means that this API is developed to access the different format and the different kind of data you can find on the WEkEO portfolio. So I would say we can apply on different data from ocean, fields, land, emergency, etc.
Right. Thanks. And next question, also on WEkEO, how can we access the Jupyter notebooks there?
Oh, it's very simple. You have just to be registered. So as I said, it's open and free. So once you are registered on your user corner, you can find the access to directly enter in the Jupyter Hub. So you have your home directory. So it's a small resources to start playing with the Jupyter Notebook available.
Excellent, thank you. There's a question from Wayne about EUMETView. So this would be for you, Noemi. Is there an attribution that they should give when sharing animations or images from EUMETView?
Well, you can just it's your image, of course. If you write that has been created with EUMETView is really strongly appreciated. But our services are free, and you are allowed to use the data. So yes, if you can, it's really appreciated. But it's still your image, you're creating it. And of course, when you download the image with the label, you will have it automatically written EUMETView. So EUMETSAT. So you can use this.
Yeah, so use EUMETView and share a lot.
Yes, please. And tag all the EUMETSAT and Copernicus as well in whatever you share. That's really appreciated.
Definitely. All right, another question. Is there a certificate of attendance? No, there's not, but we hope that the workshop lives in your hearts for many years to come. Next question is, may you please provide us with the workshop material or link? I've just posted the answers to that in the chat, so I hope you can find them there, and we'll put those in the notes for this video when you see it on YouTube. Okay, and then another one, I've downloaded satellite data from EUMETSAT in .NAT format. Please suggest the Python or Fortran script to read the data in that format. Noemi, are you able to help out here?
Yes, so you can check out on the knowledge bases what I was showing before. We have different Jupyter notebooks. Of course, native data is what we call native, but of course, depending on the data you downloaded, then you'll have a different format. For example, you want Sentinel format, so then it's Sentinel format. But we do have information, and we do have a Jupyter notebook called Customizing with Data Tailor. The data tailor is basically what we use to customize our data. So if you have downloaded data in your format, but you want to transform them in GOT for a NetCDF, you're able to use that through Python. But you're also going to be able to download them through the user interface if you're not comfortable with Python scripts. We have constantly trainings that treat exactly these topics, especially data tailor, which is one of our integrated service that can be quite confusing. So definitely advise you to check out our registration page on the data access services. We are having series of webinars. So, and if you want to learn more and you want to get into a training, you can do that. And to the knowledge bases, you can just check out on the knowledge base, data tailor, data store, and you will find out how to customize this data. What we call to customize, again, it's called it's our integrated service data tailor. So we do have a Jupyter notebook. I'll send you the link of the Jupyter notebook right now.
Great, so watch the chat for that. Another comment, hoping to see some hands-on data access and processing. That was from early on. I hope that you're happy with what you saw. And as Noemi notes, we have lots of other training actions going on. So come along and engage with us, and I think you'll find something you'll like. Going on to the next one, how can we access satellite imagery, which can be easy to load onto ArcMap or QGIS? I think those resources that you were pointing to, Noemi, would be good for that. Is that correct?
Yes, exactly. So we do have for GOT format, again, you can use our integrated service data tailor. We constantly have trainings on this, and also regarding QGIS using the UMET view, you can we have sent one of the links on how to use the web mapping service through GIS. So by using, or you will just open GIS, use the web mapping service, and you will have the exact same collection that you have on UMET view right there on your QGIS. So this is also something you find in our knowledge bases, and you can find the link that Sienna sent before.
All right, thanks very much. And then another comment from Deborah. Well done, Annamaria. Deborah loves the image of the day. So do I. I think a lot of people do. So keep on making the image of the day, please. Jean de Fatima, I'm posting the Slido link. It's not slido.com. It's the address I'm posting right now. So if you want to ask questions, please go to that link. And then we have a question: is the series recorded? A few minutes ago, I posted the link to where we are at YouTube. So scroll up in the chat and you'll find where to find not only this video, but the other videos that we've made in the rest of the workshop series. And then Paul, we've got one for you. Can you provide more details about the Data Viz workshop?
Yeah, so it's the 23rd of October. We're going to be having an hour's workshop with the WCRP Open Science Conference. Off the top of my head, I can't remember the time, but yeah, it was October the 23rd. Again, details have been pushed out well before, and we'll have information starting from September.
Excellent, thank you. The next question, I think that's a duplicate of one that we answered previously. So we'll skip merrily over that and continue on to the one about R. Fabrice, do you have scripts for handling WEkEO data in R?
We have some available on the Copernicus Marine Service. If you go on the e-learning material webpage on the website, you will find different tutorial videos and codes in Python, in R, but also using our NetCDF plugin developed for using the data on QGIS. So yes, you will find some code on using RStudio.
Okay. Thank you. Yeah, and then there's also a question on embedding code to GitHub. Any insights you can offer there?
I think it's feasible, but embed the code to GitHub. I know all the Jupyter notebooks available on the Jupyter Notebook gallery are already on GitHub, and in fact, the gallery is just a representation of what is available on the different GitHub of the Copernicus entities.
Okay, yeah, that makes sense. All right, so I'm scrolling through the rest of the questions, and it looks like they get really specific and rather technical. So apologies, but as we're already 25 over, I'm going to propose we close out the meeting. We're not having any more questions that are upvoted 20 times or anything like that. So we would love to engage with you about all of these questions, though. So please reach out to us on our social media channels. You can use YouTube, you can use Twitter, you can use basically any social media you like, and we won't be able to escape. So we'll be very happy to talk with you, to help you make use of this great data, and would also be very, very happy to get your feedback on this workshop. So Rosa's just posted a request for feedback also on the Slido. Please take a look at that link and let us know what you think. We're always wanting to learn from what we've done and improve it, so any input you can provide there is appreciated. And lastly, thanks to all the panelists. Your presentations were excellent. I was really excited to see them all. Thank you very much. And I wish everybody much success and a lot of fun working with our data. Bye-bye.
Thank you, bye.
Thank you, everybody, for participating.
Bye.
Bye.